So welcome to the folding and cutting paper workshop, and we are going to start with this file. So just open in packs, inside packs there is a library, folder called Polylines, and inside VVV there is other folder called Get Power. So just open the first patch. And we are going to see here an overview of all the elements that we have in the library. So we have four types of elements, like four kind of primitives. So one is called Polyline. We have also Polygon. Polygon can be also a pyramid. This is just a triangle form. And we have also here box and surface. So as you can see, the polyline has many operations and surface as well. So they are the main data types that we are going to use on the workshop. And there is other part is based on Bezier lines. So it's much easier to work with. If you have not many experience with VVV, there is some examples based on Bezier lines, easy to set up, and you can just get results very, very easy. So, okay. So let's close this one with Control W and a new patch here. And we are going to open the basic modeling objects. So here we have, at first I'm going to explain you, we are going to use here, there is a sort of 3D view or 3D visualizer. This is our main patch to visualize all the data. So we are going to use this 3D view almost the whole time. It's on the help patches integrated, so, but just to know that this is our way to visualize the data. So it's everything prepared. You just need to connect the geometry and the polylines, and you see the things. You don't need to patch anything. So we have here, wait a moment.
We connect the spread of geometry to the 3D.
So we have here, this is a polyline, this element that we have here, and this is the polyline that we are using here. For example, if I open it, we can see the correspondence, no? And this polyline is created with just a circular array here. It's made of 15 pieces. And also you can change the diameter, yeah, the typical VVV stuff, no? And also, using this, we generate a polyline, and then this polyline is transformed here in order to connect both polylines. And in this way, we get a sort of cylinder. No? This is more or less the procedure that we are going to use during the workshop. We start with a very, very simple type or data type, and then we do something with it, and we generate maybe an extrusion or something like that, and we get a more complex object. But the idea is to start always with simple elements, and we make it more complex, adding more operations and transforming it. So this is more or less the thing. We have, for example, here, this is other data type. This is a surface. In this case, it's a spherical surface, but we have many ways to generate a surface. All the surfaces used in this library are grid-based. So it's not really possible right now to use any kind of manifold surfaces or meshes. but this is one thing that I'm going to improve for the next edition. And also we have other data type is called box. It's just an easy way to generate boxes, but it's just an abstraction of a surface. So if you want to see here, there is on the right side, there is the unfold process, what I call unfold process, or you can call it unwrap, or yeah, there is many ways to call it. It's just to get the 3D object in 3D space and split it in many parts and put it into the horizontal plane, just ready to send to the plotter. This is the idea, more or less. If we want to enable this visualizer, this is the unfold data view. So one thing is the 3D view, and the other one is the unfold data view. No, one is 3D, the other one is 2D. And there is one 2D camera integrated already in the patch, so you don't need to patch any camera. To control the 2D camera is just with the right mouse and the wheel. And to control the 3D camera, you have to press space. And this is the normal orbit camera that you can find in VVV. So this is more or less the way of working. Okay. Did I miss something, no?
Simplicity. So he explained me yesterday, so I'm not he's very into the deep, but what I get, and it's really cool, that everything only what you need, you can show it with the mouse if they would. So it's more or less here he defines, this is the parallels, he defines the graphics, so the geometry. And the rest here is only a viewer, that what you see it, and the rest of the magic is this unfold back. So it's only the whole pipeline, it's always the same. And he will show now a lot of complex things, what you can do with geometry and all this stuff. This is part one. This is just unfolding, and this is just visualizing. And unfolding and visualizing, always the same, because it does only the same job. And the whole weird magic for me yesterday was more in this geometry stuff.
Well,
so just to get that there is simple, only 3 parts. Define the geometry, unfold it, and visualize it in VVV.
And also we have here, we can add a Svg Writer that I forgot to put it here. And this Svg Writer works with any unfold patch. So for example, we have polygon unfold, surface unfold, and box unfold. And they are compatible with the Svg Writer. So if we add it, we can see that here we get the SVG file. We can save it. Here, for example, you can choose a folder, and here you can choose the name of the file. You don't need to add any suffix. So yeah, just to let you know. This little patch, the Svg Writer, is a bit expensive on the CPU, so we just use it at the end. But the whole workflow happens on the DirectX 11 pipeline, so the visualization and these kind of things. So
the unfolding as well is also computed.
No. Unfolding is happening on VL. Sorry, I did it wrong.
Okay. But on the CPU? Or?
It's everything on CPU, and the visualization is in GPU. Yeah. Yeah? Sorry? How I scale it? Yeah, because it's automatically scaled. So if you connect for example, the surface here instead of polygon, it's automatically scaled. So and also if you can see here, there is a red alarm it means the document exceeds the Illustrator maximum size. So the maximum size is like 577 centimeters. I don't know, it's something with inches or something like that. So just to keep in mind that if you see here something red, you have to change the way of distribute the elements. I'm going to explain that later. So this is just a brief introduction about the pipeline. And I'm going to close this one and go to other example. So 2D patterns. This is the second one. Just double click or drag and drop on the gray thing, and we have here some kind of 2D patterns. The output of those 2D patterns, for example, for the quad grid, is polygon, and also we get the polylines. So we can choose both of them. So depending on the situation, you will need or polygon or polyline. So it's quite handy to have both. And for example, band grid, this is the last element. The output is based on polylines. So if you need to convert it to surface, there is some nodes to convert stripes to surface, or yeah. I'm going to explain you later the ways to change from polygon to polyline, or to polyline to surface, or these kind of things, which is quite handy. And also, for example, in the grid, in the quad grid, you can change the resolution of an element. So let's say the default resolution is 4, it's a square, but you can change it. So, and we have also the hexagonal or hexagrid. You can change many parameters on the pattern, and also the shape of the pattern. So you can get this kind of rhombus pattern. This is not anymore an hexagon. This is a 4-point polygon, and this is also other kind of shape. So you're pretty flexible to generate any kind of shape with those simple elements, simple patterns. Let's go to the next one. So we are going to use these elements very often during the process. So don't worry if you don't get right now the 100% of the thing. So let's close it. And for example, we are going to talk later about analysis. Let's start the fourth one, converters. So this is just a way to convert between data types. So you can convert between, for example, this is a polyline element. This is part of a polyline library that Jorek did. So you just connect it to the polygon, and this is already a polygon. But in order to get a polygon, you need to add a center point. Which also this little module is enough intelligent to generate his own center point. If you don't add the center point, you can estimate it in some way. So it generates the mean point, and it adds as a center, so it's very easy. But sometimes you need to add an extra, so the center point is not on the same coplanar plane than the points, but you can extrude it, and you can work with the polygon as a pyramid or something like that. No? Do you understand more or less? And do you listen me? Do you hear me? Or should I talk louder? Okay. Okay. This is polyline to polygon, and also you can convert it again to polyline, no? And you get the center point here. So the perimeter as a polyline, and the center as a point, a 3D point. Okay. Here, for example, here in this part, in the middle part, we have the spherical surface that we saw before. We can change the resolution and also the cycle. This is the offset on the v-axis, but you can change also the cycle on both axes. So it's quite handy to work with it. And you can convert it and split it in many things. For example, you can get just the quads of a surface, or you can get the triangles, or the UV polylines. No? I'm going to show you just the UV polylines. I'm going to connect this guy. This is a polyline output to the polyline input in the 3D view. And there is other button here. Okay, sorry. There is an index here. You can see. Do you see that? What I did? So there is here an index pin, and I just add an IO box. And with the index pin, we can choose between the many polylines. This is just as a visualization tool, so it's very helpful, also healthy. When you are dealing with a lot of objects and you have to know, okay, which number is this one? I don't know, so I have my object here in the reality, and I cannot connect it because I don't see it. So this is a way to simplify the visualization process. For example, here we have the other kind of element, the band grid that we saw already, and we can convert it into surface. This surface actually is generated many surfaces, one surface per band. No? We have many bands here. Okay, here actually you can choose the amount of bands, and any band is one stripe, it's one surface, and the resolution is 2 by the number of cells that the grid has. Yeah. And also here, to finish this part, we have a box. So we can generate boxes in many ways. For example, we can define all the points of the box and then transform it, or you can define the box with a top polyline or a bottom polyline. So maybe you are working with polylines and you get, for example, from the surface the quads, and using these quads you can generate boxes. So this is the thing about the transformations and the converters. So it makes the life easier, I think. So if you don't understand anything, there is some help patches. For example, for I think Bangrid has his own help patch. Also, Spherical Surface has his own help patch. Not all the elements has a help patch. Sorry, I didn't have the time to finish it. But in the next edition, I think everything has help patches.
I have a question. When you selected the ball and the circle around this with the index, I only select the face of the whole sphere, but not like you did.
Yeah, because you need to connect this guy.
Okay.
Yeah, it was already connected it was already connected to quads, so it was here, and this is the reason because you saw just quads. But if you connect the split polylines, you are able to see the UV lines, and also you can choose the V instead U, So you can see, you can visualize the UV lines in the other direction. No? And also there is some cons and zip nodes in order to work with polyline and surface. Yeah. So if you need to connect many polylines just to visualize it or just to send it to other process, you can do it. It's ready. And also to finish this part, so you can split everything on numbers, on vectors. So maybe at the end you need to convert it into vectors to do some calculations, or you have to do something that is not possible already in parallel. So you can always go into the VB world in vectors or numbers and get again into parallel world. No? You got it more or less? Or? Okay, let's close this example. And we are going to analysis. This is just, we are not going to use it so much, but it's good to know that we can get the real scale, so with the real size of the objects. If you can see here, we have a grid here, and this grid is not in VB units, it's in SVG units. So every brown or orange square is 1 square meter, and every grid cell is 20 centimeters, so more or less. This is just as a reference. When you are working with a tool, you can graphically see how big is your object. So, but this is just a reference. And also there is some analysis tools. You can get for example here, if you draw the polyline, you can get the total length of the polyline in centimeters here, or in VB units. No? And also the bounding box in centimeters and in VB units. And the area, some analysis things. Also, center of mass is based on the area of the object, not on the position of the vertices. So it works in other fashion. And yeah, this is pretty much what we can do in regarding to analysis. So. Did you understand more or less? This is not a big part, but it's nice to know that it exists. So.
What is the size of the polyline?
It's the length of the polyline.
Oh.
The perimeter.
Okay.
Or so you divide it in segments, the polyline, and you just yeah. It's just the length of the polyline. And for example, just open transformations. So in transformations we have, for example, I'm going to explain what a transformation is. It's just when we transform an object, we don't change the morphology of the object. We just translate it, scale it, and rotate it. So, for example, extrusion works in this fashion. So we have a origin polyline, for example, here, and we add where is it? Here. This is our offset factor, no? But this, as you can see, both polylines are identical. So both objects are identical. I just translate it and scale it a bit. So there is no morphology changes. I'm not changing the amount of points. I'm not changing the position of one single point. I'm changing the whole object. This is the basis of transformations. So in this case, I did a bit complex example. So I generate a polyline here. which you can close or you can tweak with a factor parameter. And also with this polyline, I transformed it just to put it in the other plane, just to visualize. And I did an extrusion here. So this extrusion is equally for the both extrusion nodes. One of them is extrusion polyline, this one, and this is extrusion polygon. But they work more or less in the same way. So polyline extrusion is a bit more complex. You have some extra features. You can add extra resolution to the generated surface, and in the extrusion polygon you are not so flexible. But I want to keep it more simple, this extrusion polygon, and we are going to use more the extrusion polyline, so it's more flexible and you can do more funky stuff with it. So, and also there is other kind of transformations. So for example, blend. If you want to open the help patch, the blend help patch, just press F1. This is pretty much the same than the other one. A blend is just an interpolation between two elements. In this case, two polylines. No, we are interpolating. For example, this the first polyline. The first polyline, let's see, okay, this is the rotation, let me check it, wow, this is the other rotation. Okay, that would be the default state of this element, no? And then we can maybe rotate one of the polylines and we can get this kind of weird shapes. So just with two polylines connecting them. So. And also here we can select the resolution of how many interpolations I need. And here the resolution of the origin of the start polyline. And as you can see, I'm working all the time with one polyline. I transform it and I connect it both. So I connect both. So it's, you can use maybe two different elements. Yeah?
I was going to say, can you do two different polylines with different resolutions? So like
no, you have to keep the same resolution. So maybe you are working with a star instead of circle. There is other little module called a star, and you have to keep the same resolution on both elements. So if not, it doesn't work. Yeah. Let's close the blend and open other little example here. On the right down part, we have other transformation process called loft. And this is pretty much the same than blend, but you can add an extra polyline to make the path, no? So you have one polyline here, and with blend you just connect it. So it's sort of a stupid thing. But the loft is more intelligent, and you can define a path. So, and not only a path, but some additional transformations. You can disconnect this pin with a right mouse click, and this is the original element. So this is just a loft between a start shape, as you can see here, more or less.
Which one did you disconnect?
The last one. So the additional transformation, just disconnected, and you just get the interpolation, the loft interpolation between the two elements following this path. No? And the path is defined by a spiral spread that is part of a Polyline library that Jorek did. So, and also you can add your own transformations here, not just scaling, but rotating and translating. So it's quite handy, the loft. So we use a lot loft process in this kind of way of designing. So it's very, very handy. And also there is a very similar process to loft. It's called sweep. If you want to close this and open the next example, so we have here a sweep. And it's pretty much the same than loft, but instead of using two polylines to define the shape of the body, you use just one. And other one to define the path of the element. No? They are pretty much the same, but in loft you use two polylines to define the shape, and in this one you use just one. Yeah. And you can see here all the interpolated polylines. As you can see, I'm not changing the morphology of the polylines. They have the same amount of points, and they are always keeping the same shape. But we are not adding elements. We are not transforming one single element and moving it. So the morphology is always exactly than the original morphology. Do you get it? This is not really relevant, but it's nice to see the difference between modifiers and transformers. So, and if you want, we can close this one, and we can go to the revolve process. This is one of the most famous ones. So, surface of revolution is just generate a surface rotating an element along an axis. So actually we can select the axis here on the right side. For example, there is three axes. Yeah. And we can get different kind of object depending on the axis. So this is the default way, no? And also we can rotate the polyline. Yeah, it's very useful. So, okay, and also you can change the resolution. Yeah. Okay, everything good. Yeah. So close this little guy and the transformations, and we are going to talk now about modifiers. Just some little examples. Modifiers. For example, here, if you remember the 2D patterns that we saw a couple of patches ago, so we have here an hexagonal grid on the right side. Let me a moment. Okay, here. This is just an hexagonal grid, and we are just wrapping this hexagonal grid over a surface. This is a very common process in architecture and this kind of parametric design workflow. So this is I think this is the most common way to generate kind of surface like that with hexagonal or honeycomb shapes. But we can pretty much add any kind of 2D pattern to a surface, a Voronoi pattern or whatever. So just keep in mind that you have generate at first polygon or polyline and then fold it into the surface using this process called panelizer. And we have also other kind of modifiers. For example, I prepared a little example here. You have to connect here and also connect here in the 3D view. And you can connect also the polylines here. And as you can see, we get a very Yeah, it's based on the same object that we have already, but I applied some modifiers to the original polyline. So I round the corners, but I'm changing the morphology of the object. So I'm adding more points, and I'm also changing the shape. I'm making more softer. This is how a modifier works. Also, Panelizer works as a modifier. We are getting a 2D object, which is coplanar. All the points are on the same plane, and we are put it on a 3D object. So we are changing the position of any single point of this primitive. More or less clear? Yeah. Any question or anything?
I'm angry about it.
Okay. So there is also a help patch for, yeah, it's pretty much the same. So, as you can see here, the outside of a surface is black, so it means that the normals are flipped. So you can change it here. You can reverse the element. So what you see in the parallel library, for example, if you see that a face is facing you, and you unfolded it, you are going to unfold it in this way. So if you, let's say, for example, we have a pyramid in this direction, and you see, and the normals are flipped out, and you unfold it, you are going to get a flipped object also. Do you get it, more or less?
So the normals have the point inwards.
Yeah.
To be the same.
Or maybe if you want to get the opposite effect, you flip the normals. You work with the normals in the other direction. But just to keep in mind that what you see here on the 3D model, the normals are facing to you, is going to be represented on the unfold process. So more or less, yeah. Maybe I'm not being very clear, but you can get it after. So.
Does it affect like which parts of you the class will get, and where you need to glue them together and stuff like that?
Yeah. So if the whole model is flipped, you have to know that. So because all the numbers are inverted and everything is inverted, everything is flipped, and instead of starting from this point to this point, you are starting in the other direction. So.
Yeah, an example for example would be if you now extrude here from this in the middle and you go out, so they go out. But when you want it to go in, then you have to reverse it. The face is looking inside, and then you go in. Mm-hmm. So you have that. This is the whole process. This is more interesting, I think, and more needed when you work with it in another direction, because when you unfold it, most of the time it's no problem which side you look.
But in some situations, if the model is flipped, you get totally different 2D parts, so the printing parts.
Okay.
It's just to keep in mind that if it looks nice on the screen, it's going to be the same on the paper, so more or less. So.
Isn't it more common to work with the normals pointing outwards?
Yeah, this is the way. So.
And then, why did you do it the other way around?
Because sometimes you need to flip the normals. For example, you need an extrusion based on other parameters, but those parameters you don't want to transform or divide by -1 or something like that. So sometimes it's better to flip the object, generate an extrusion, and then the extrusion is in the correct way. But forget it. So I'm overthinking. So, but it's going to be easier to use. Don't worry about that. So if you want to close it, we are going to for example, I don't know. Let's go to the examples before to go to the surface modeling. Let's go to the examples. also here a scene template. Oh, okay. This is just a very, very simple example and some annotations for you to work with both modules, so the 3D view and the unfold data view. As you can see, the unfold data view needs the resolution of the renderer, and I put this send on receive, just to keep in mind that it works in this way. So. And also the 3D camera works with a space, pressing a space, and the 2D camera that we are not using at the moment works with a wheel and the right mouse. Yeah. Just close it. Let's go to open the first real example. So, as you can see here, we have an hexagonal grid in 2D, and we are just setting the centers. So we are getting the polygons here. Those are polygons. And there is a module to transform just the centers. I get the polygon and I add a new center. The old center is gone. So. And these center positions are based on some formula, some relationship. You can do it. Keep in mind that you have to add the same amount of centers than the same amount of elements. So if we have 175 elements, you have to add the same amount. So just keep in mind that. And also we can go into the unfold part and enable it, and we get all the pieces here. So you can see there are many kind of, there are some tabs to glue it together, but we can also use other kind of tab distributions or inlines. So we can change without dash on the tabs position, or without the diagonals. So, and also, for example, the dash offset. So you can see here. So we can change many parameters on the tab design of flag. How do you say it in English? Tabs, flaps, or
Flaps.
flaps? Yeah. Okay. I use this notation. Yeah, and also you can get rid of flaps if you want. Maybe you don't need it. So you have some many ways to tweak with 2D building parts. So, and also there is other kind of tabs. It's called a lock tab. It's when you are working, when you need to put the tab in a hole, so, and it works like a traction element. So it has some little gaps. So yeah, but I will recommend you, if you are interested on it, just spend some days tweaking and trying with the whole patches. So there is many parameters, and if we talk about all the topics, we don't finish the workshop. And the goal of the workshop is to fabricate something, no? Okay. So this is a nice example to start, for example, but I would like to make an overview of all the examples, and then you choose whatever you like and you start to work with it. Okay. So let's close this one and open the second one. It's called box array. And this one is based on pretty much on the same principle. So you have an array of elements in 2D. I define that with a tree map. This is an operation in BBB, so you define just some points and in 2D space, and it fills the space with many elements. So, yeah. If you want to know more about that, you can open the help page of TreeMap, and you get the idea. So, this is just a way to draw elements in 2D space. And also we have here the box. Also, if you want, you can open the help page to see the box. This is one single box, and you define the up corners or top corners and bottom corners. This is not the best way to define a box. I prefer to use polylines, the top polyline and bottom polyline, and it's much easier in some way, in some situations. So let's close this little help page and talk a bit about the box array. So you can see we have also the unfold data, and we get automatic, now. Sometimes you have to press set to generate all the pieces. So don't forget it. And on the box unfold element, we have some features also. We can select the kind of inlines, the dash mode, adding diagonals, and also the amount of lines. So it's pretty much the same than in the other one. And also the dash offset is, yeah. And also the tab size. So, but this is more or less 1 centimeter long. I think it's enough to work with. So, more or less clear. I'm going to quickly or not. Is it okay? Okay, perfect. So let's close this example, and we are going to talk now about transformations, so extrusions. If you remember the first example, we got an hexagonal grid and we convert it into polygon, and we just take the center point and we move it. This is a similar operation. So we have a hexagonal grid, and then instead of generating a polygon and then taking the center point, we are extruding the hexagon, no? With the extrusion that we have here. This is the length of the extrusion. Let me focus a bit. And also we can control also the size. I just applied a linear spread on the size, the same amount of elements that we have. But for example, if we disconnect that and press Alt right mouse to make it default, now the size is 0. So you can see here there is just a normal extrusion. So with this method, we can generate pyramids or truncated pyramids or just a cylinder. And also, as we saw before, we can change also the resolution here, adding more resolution. This is relevant if you need to do other extra process with the mesh. So in this case, it doesn't make any sense because it's coplanar, and adding more resolution is just adding more points to the final blueprint. So, but it's good to know that is it possible, and in some situations, it's quite handy to have these features. Yeah, Daniel, good.
For me, it's clear.
Okay.
Where's the option to close all these bottom part?
The bottom and the top,
yeah.
You have to generate a polygon. So, for example, actually the base is already there. It's the hexagonal grid. So you can just call here from Polygon DirectX 11 and connect it here. We need also a cons geometry. There's a cons geometry. Here. For example, I'm going to connect it before, and you need also to update it. So you can see we have the base here, no? And also the side, here, base side. And what we need is to add other new polygon. Here we can add a new pin. We can connect it to the, let's see. Okay. We need to convert from polyline, the top polyline, to polygon. Do you see that? This little pin here? For example, with converters that we saw in the other help patch. So there is one called to polygon. Top to polygon. We just generate the center automatically, so we are not defining a new center. We connect it to the from polygon in order to visualize. It's not visible. Okay, let's see. As you can see, many nodes has a set pin, because we are using very expensive processes for the CPU. So this is not a real-time operation. So we are modeling. So we are not making visuals. We don't need to render every frame, the whole process. So sometimes you need, when you have maybe 10,000 elements, you don't need to render that on every frame. You just need to render when you update that. But now I don't know why it's not working properly. Is it generated? They are there. So the top part is flipped also. But in the two polygon we can flip it. So it's okay. So the most of the converters has also a reverse and a close, so you can flip. It's quite handy. And now you get a closed truncated pyramid. So the only thing that you need to unwrap or unfold the three parts in different modules. So
you have to glue them together afterwards.
Sorry?
You will get them as separate pieces and you will have to glue them together.
Yeah, you get the side, you get the top and the bottom, and you glue it together. In this case, so I have to prepare in the future just a module like a box, but for prism, for example, and you get the bottom and the top automatically glue everything together. So you don't need to generate all the pieces and then put it together. Yeah. But for now, I think it's quite handy to work with. So we don't need to generate a new data type for that. So if you want to save it. And if not, we are... sorry, I forgot to talk about the unfold process in this part. So, and the most relevant part of this design is the surface, the border, no? So let's put the resolution in 0 again. If you change it, and let's generate, so set, and this guy is going to generate all the side parts which are equal. So all the truncated pyramids are the same in this example. So you get maybe all the pieces look the same. but you can change maybe here, as it was, the scale of extrusion, and then generate here, so update again, and all the pieces should look differently. So if we generate again, we can see that all the pieces look different. Maybe it's easier. Okay. Yeah, until here it's more or less clear, no? And also, border was off. Okay. In the surface and unfold module, we have some. Hey, what is happening here? Okay. So we can choose. Maybe I don't need the tabs on the top because the top polygon has already flaps, so I don't need to add it. So you can choose it here. There is so many options on the unfold module. So you can get rid of upper tabs or the down tabs. So. And also, if you want, you can get rid of the whole flaps, but it doesn't make any sense. So, yeah. Okay. More or less clear, this little example. So extrusion, I think you are pretty much familiar with this kind of transformation. So extrusion is one of the most popular one. So let's go to the next example. It's called sweep polylines. This is pretty much the same example that we saw already. And in order to work with it, we need. I didn't put everything here, so, but you can get the, for example, unfold surface, and you can connect it to the surface output of a sweep, for example here, to this guy. And also unfold data view. This is our way to visualize the 2D data, and we connect it here. And this module has an output just to connect here, just a layer. So we press set here. One little thing. So as you remember, I mentioned that the unfold data view needs the render resolution to work. Yeah, it's a bit weird. So we can just connect it directly like that, or via send. So this is not really elegant, but I need to find a workaround. And you get all the pieces. So all the pieces in this direction. So this is our object, and we are unrolling the pieces in this direction. But we can also choose the other direction, so the longest direction, so, which is not really practical because we are working with a small size plotter. And maybe this piece is like 2 meters long, but it looks nice. So for the moment, and also you can see here some red parts on the blueprint part on the SVG. It means that you are exceeding maybe so your parts are bigger than this maximum size. This is my maximum paper size. So it's quite nice to have it here as a sort of, hey, this is too big, try out, try to sectorize or try other way to unfold or unwrap the model, no?
And where is the paper size?
Here in the unfold data view, but this is just to visualize. This is just an alarm, so it's telling you, hey guy, so this is too big, take care with it. Maybe you need to put on the paper diagonally, not in, yeah.
And all the units are in centimeters?
Yeah, centimeters, but area is in square meters. If you get a area module, it's in square meters. But the rest is in centimeters. So, yeah. And also in this module, you have also to check the border. In order to get tabs on or flaps on the whole perimeter, no? And also in the surface unroll, we can select interlocked tabs. So instead of glue tabs, we can work with interlocked tabs, which is much faster. So for prototyping, you don't need to glue everything. So maybe you just want to try out some pieces very quickly, and in 1 hour you can mount it. And if you are using glue tabs, it's a bit tricky, but the output is much better. So mostly for mapping or...
This thing you mount in 1 hour?
Not this thing, but maybe a piece with 40 pieces. Yeah, you can mount it in maybe in 2 hours.
Just to say that this is not... when I see this, and yesterday we made this you cannot handle in 1 hour. I'm very impressed. But Ari, you can...
I mean, with the interlocked tabs and some practice, yeah, you watch a movie, and at the end you have something beautiful. Yeah, and also it's very, very meditative. And also it's, when you are designing, it's other kind of mood, and when you are fabricating the object, it's totally different. So, I mean the energy. So, okay.
How do I get the tabs?
Eh?
How do I enable the tabs?
Enable this kind of interlocked tabs here. Tabs or interlocked. So, and also,
border settings that you have to activate.
yeah, this is a bit weird. So maybe I have to change it. And also you have to close a stripe if you want. So this is other way to connect several strips or stripes. Yeah, there is many ways to connect strips or stripes together. So, you got it, more or less? Any questions about that? About tabs and also in the surface and roll, we have some extra features like holes. So this is interesting when you are dealing not just a decorative element, but as a functional element. Sometimes the object is too complex that you are not able to fabricate it. You need some holes to put your fingers and to put it together. So this is more or less the reason I'm using holes. So this is not really a decorative thing, so, but you can use it as a decorative element. So. And welcome to Jörg, which is a part of the library. So he did the first prototype of a Polyline part, and I just expanded. So, yeah.
How do you actually get tabs in all the pieces that you have there? Because right now it's only one piece that gets the tabs.
Yeah. You have to close, you have to press, I think it's close border. This is one thing.
Right now you just have one of all the pieces.
Do you mean that? No, this is not possible because there is a lot of data, and if I do that with maybe with 1,000 elements, so the computer doesn't react in a good way.
It works in the SVG.
Yeah, in SVG, this is just a way to visualize the data. So you can do it, for example, here. in the unfold data view, you have an index bin. So you can put it in -1, and you get all the pieces with the decoration. In this case, it's not really bad, but when you are dealing with maybe 5,000 elements, you just need to visualize the perimeter and the tabs. You imagine that so, in some way. But because of performance reasons. But in the SVG file, it's going to be fine. So don't worry about that. So any questions regarding to sweep polylines? No, it's quite easy, no? So let's close this guy or save it if you want. Keep it. I'm not going to save it. And let's talk about sectorization. So for example, sometimes you have a big piece and you have to cut it in many pieces in order to fabricate it. And this is the motivation for sectorizer. So just depending on UV lines, you define sectors. Also. And also it works for closed geometries. So this is quite good. But this is just relevant if you are dealing with big elements. So just to mention that it exists and you can use it, and instead of having one surface, you get many pieces of this surface. But they are already surface, so you don't need to change the data type or something like that. Okay.
In this case, if you use the it's a big principle, basically, something like that, and then set it out instead, so sheets.
Yeah, and also the stripes are going to have the resolution of this little sector. So if you remember, when I unfold this little bag, in the horizontal way, we got these very long stripes. But if you sectorize, you are still able to unroll it in this direction. Maybe you like this direction, but your paper size is not enough, and you can sectorize it. And you are keeping the same tabs, the same stripes direction. So. And also you can say, okay, in the U direction it's going to be close, so, or in the V direction it's going to be close. If both are close, there is no sectorization. And also, if you make a mistake in setting the data, setting the UV lines, you get an error message here. You need at least 2 slices. So here, 2 slices on every axis minimum. So some little help. Yeah, this is pretty much everything about sectorize. Yeah, this is a more complex example. So mixing loft. This is the thing that I mentioned before. So we have this big bag, and I sectorize the bag in many pieces, many slices. No? And if we go to the SVG, to the unfold process, and enable it, we see that we get the pieces per sector. And also the numeration is divided by sectors. So we have 00, 01, 02, and go on, and 10, 12, no, 10, 11, 12. So depending on the sector. So you don't need to define any kind of numeration. So it's everything depending on the amount of surfaces you have already in the model. Also, if you want, you can add some prefix. This is common for all the unfold elements. For example, A, and you get an A at the beginning. Yeah.
And you can input the spread of strings and get them on different sectors? Or?
I didn't check it. Let me see if it's possible. Take care with the spreads and those modules. Not all the things are spreadable. So using in the way I'm showing you, you can try, but maybe not all the modules work in the same fashion. So maybe some modules are not all the pins are spreadable. So just keep in mind that this is a bit experimental already. So, and I think this one, so the prefix is not spreadable in this way. No, so it's just per surface. No. Okay. So for the unfold elements, there is not a help patch, but I think it's enough. Just to take a look to the other help patches and other examples. We are using all the time these modules, so I didn't need any help patch for that. So any question? Is more or less clear how to work with the sectorizer and many surfaces. Yeah. Daniel?
I'm fine.
You are fine. Okay, cool. If you are fine, I'm fine. Also, we can save the surfaces as on the disk. So there is a writer and a reader, for example.
What kind of format is this?
This is a surf format.
You invented.
I invented. If you like beach sports, surfing and these kind of things. Yeah, and it's very light. So as you can see, it's like it's less than 1K, so 1 MB. Sorry. And
only vertices in it, really.
Sorry.
The surf is just a kind of X file, but only vertices are written.
Yeah, it works just in this framework. So this is just indices and points. I'm not putting normals or something like that, or texture coordinates. The normals and texture coordinates are generated on DirectX 11, so on those little modules. We don't need really the normals to generate the objects. So, and also the texture coordinates are relevant if you are using the object to make a sort of mapping, and you need the texture coordinates in your OBJ file, or yeah. It's not relevant for fabrication. So, hey, sorry. Okay. So this example is more or less clear. No? Any question? Okay, let's go to the next one. So, paneling. We saw already the paneling processing, the paneling process. It was I take something in 2D and I have a surface in 3D and I put my 2D thing on the surface. This is more or less how it works. But for example, in some situations, when we are adding a polygon on a surface, and when we unwrap it, we get an open polygon, sort of a pyramid, but the center is very low. It's very close to the plane that all the points share. No? In some situations, you are going to have a very uncomfortable gap between, so at the end of the piece, so a little gap, and you are not really able to work with these pieces. So this is the reason I made this kind of process. Is called a flat polygon. So I'm going to explain that maybe before in other way, easier to understand. Also, I saw that the people have some problems to understand this little process, but it's pretty much I'm getting the polygon and I'm interpolating the center until the sum of all the triangles are 360. At the end, when I unfold it, I have a closed thing. So all the triangles, the whole sum of the triangles is 360. So it's a closed thing. It's just a fake, more or less. So the contour points of this element on the surface of this guy are the same, remain the same, but I'm just changing the center position until I get a closed polygon. So it's a bit weird, but it's quite handy. In this way, we don't need to glue all together we don't need to close the polygon. So in some way, am I explaining that good, Daniel? Do you understand it from yesterday,
I know it.
or maybe you have other way to explain it better than me, or?
I just learned a little track because I was thinking about.
So maybe it's better if we, yeah.
Do you have a physical example?
Yeah. So if we go to the panelizer, sorry, to flat polygon example, I think it's a bit more clear. So we have the original element. This is pretty much the same element, as you can see. So the points, the morphology is pretty much the same. The only difference is the center point. So you can see, no? Actually, I'm going to change it again. And I'm going to calculate again, and it remains in the same way, no? And also we can change the center position. So for every polygon, there is two solutions. So it's like you have your contour here, and you are interpolating in this direction until the polygon is closed. So, okay, this is a right spot, okay. But in the other part, there is a twin of this point. So you have always two solutions. You have to choose one of them, or the upper or the down part. So this is pretty much the same. And you have also an tolerance factor and iteration factor. So not all the polygons take the same time to be flattened. So this process is a bit CPU expensive, but it's happening on the background, so you don't need to think about that. So, do you understand more or less this little thing? So, okay.
How do I choose the upper instead of the lower one?
Yeah, this is just a taste decision.
But where do I change it?
This is the center side. Center side. Yeah. And also, if you disable the approximation, you get the same object. As you can see, they are the same. No? If I change it here and I press calculate, it's the same.
I don't really get it why this is needed, but
Don't worry. Yeah. In the next example, I think you are going to get it. So let's close this guy also, and let's go to the hexagrid panelization. What happened here? Okay. So as you can see, we have here two meshes, two overlapped meshes. So if you want, we can disconnect this one. This is the original one, and this is the flattened one, the second one. They look different in some way, no? For example, I'm going to the unfold part, I'm going to enable. And to see the difference between the two meshes, we can disable the approximation enable. Okay, what happened here with the pieces? They all have a little gap in between. Not all of them, but many of them has maybe 1 millimeter gap in between. So this makes the piece very, very weak. And also you need to put tape and you need to add extra material. It's not a really nice way to work, no? Hi, Dimitri. So if you want to get rid of these little gaps and you don't mind if your surface change a bit, so it's just a bit, you can apply the approximation. And it tries to find the right position of a center in order to get a closed polygon. Yeah? You get it? It's more clear now than before? Yeah. This is just a workaround to simplify our life during the fabrication process. Yeah.
Can you repeat what's actually happening here? Just
Yeah.
to make sure
Yeah.
I really understand.
Maybe you
First
say
thing is
better.
you have the shape.
Yeah.
Second step is you want to apply this script on top of the shape because you want to have this hexagon type
Yeah.
of material.
Honeycomb. Yeah.
But it's kind of not perfect because this approximation, or this
This
overlapping,
panelization process.
is creating some mistakes or holes. And when you enable the approximation that you're doing here on this polygon module, you will try to optimize the whole thing so it actually will be a good result when doing the counting.
Yeah, this is the main goal. Yeah. But when we do the approximation process, we are just changing the center position of the polygon. So the other points remain in the same original position, and we just change the center position of the polygon, so automatically. So here the application looks for the right spot until it has closed polygons. So don't overthink about that. So this is a nice way to get closed polygons at the end, and it makes your life easier.
Is the polygon not planar?
No, in the 3D model, not. In 3D space, it's not planar, but in 2D space, it's planar. So, and when you fold it and transform it, you get a sort of little pyramid, a regular pyramid. But the base is...
Yeah, but then it's not, in the end, it's not a polygon then.
No, it's not really a polygon. This is a nomenclature.
In the end, it's a collection of polygons.
We call it a triangle fan.
Yeah, exactly.
Yeah, yeah.
But so the center point of the triangle funnel, that is what is changed.
Yeah, just the center
think
point.
of the end result.
Yeah, this is the idea.
Because changing the center of a polygon, a planar polygon, shouldn't make any difference. I mean, there is no such thing as a...
Yeah, this is an abstraction.
Yeah.
I could call it pyramids, but I think the nomenclature is more clear if I use the word polygon in some way.
Yeah, I mean, it just has to be clear to the users of the library.
Yeah. Actually, I explained that at the beginning. So polygon is not really a polygon. It can be many things.
Yeah.
This is a way to represent a triangle fan.
Yeah.
It can be a flat polygon, it can be a pyramid, it can be many things.
Okay, great.
So, yeah, it's a way to name it, but okay. It's like Polyline. So yeah, Polyline is just a line, but if you close it and if you add a center, yeah.
Yeah, it's just a 2D, 3D kind of conflict.
Yeah.
With the polygon as normally a planar surface.
Yeah.
But whatever.
Yeah, maybe it's not really the best nomenclature, but yeah, there is other tools using the same kind of nomenclature. For example, in Grasshopper, we have also the concept of not flat polygon. Yeah. And also Polyline. So yeah, I try to keep the same kind of nomenclature in parallel. that in Grasshopper, more or less, kind of. Not all the elements are called in the same way, but okay. So, and let's see the last three examples. For example, the diagonal grid panelization. For example, we are using the same 3D model, and instead of using a honeycomb pattern, we are using the band grid pattern also. We can change the amount of elements. So this is a bit CPU intense, but it's happening, as I said, in background. As you can see, there is a gap on the model. So this is one thing that you have to define manually. So in the panelizer. The panelizer, not in the panelizer, but in the 2D pattern. No? So normally it works in a UV way. So the center is in 0,5, 0,5, and the size is 1 unit. But sometimes in some situations, you have to define the center manually and also the scale manually in order to get a closed shape. No? So if we go again to the original amount of elements, I did already some calculations. I was tweaking a bit until I get the closest shape. And using the band grid, so you get this kind of shape also. I add some points on the intersections, and you can connect all the bands with each other. So with yeah, more or less clear the way to use this.
But you just have to try out and tweak by hand. So
Yeah.
Get a close shape. There is no kind of analytic way to do it.
There is a kind of analytic way to do that, but there was no time to implement it, and I think it's not too bad. So also, yeah, it would be nice to have this option, so do that automatically, but sometimes you don't need to apply your 2D pattern on the whole object. So you just need, you are interested maybe in one part, or just exploring some shapes, and you are not working with the whole surface. So this is more or less the point, but it could be better if I have an automatic way to do that. Yeah. For the next one. Yeah. So do you get it more or less? This is very similar to the other example, no? So close it. Let's open the number 10. I'm using here also panelization, but in another way. So I'm panelizing the grid, but the other grid, so I'm panelizing one grid, and the other one is on the horizontal plane without any modification on the morphology. So you can see here, we have the upper one, and when I get the upper one, I just flat the upper one and I transform it. So I transform the scale and I make it flat. And then I connect both. And you can get this kind of wall structure, so a regular wall structure based on a previous surface. So.
Can you walk us through step by step?
Yeah. For example, we have here the band grid, no? This is our main 2D element to generate the shape. And also a surface. The surface that I'm using for many examples. So the panelizer needs polylines and surface. No? When we
visualize the surface, the raw surface, so that we know actually what is the source for this whole thing, because it looks really cool, but I want to know what step happens.
No, it's quite easy. I'm going to show you. So here. And original, no, better maybe here. When it's complete, I read it. And I'm going to connect it here. For example, wait. This is our original surface. Yeah. Good point, Matthias. And based on this surface, I do the first panelization, which is happening here, which is this little guy. So forget those guys. This is the first process. I panelize this grid band, and then I take this polyline, the result of the panelizations as a polyline, and I just, in the y-axis, I just put 0. So I want a flat thing in this way. So you can see here, if I connect it, okay, it's this one. If I connect it and disconnect this one, I have just a copy of the same element, but on the 2D plane, so very, very flat. And then what I do at the end is to connect both, so the down one with the upper one, with a blend. Yeah. Do you get it? So it's...
Could you do a loft here as well?
You can do a loft if you want. Yeah, and you can get maybe other kind of...
The loft is more used if you want a path.
Yeah. But it could be possible also. Maybe not in this particular case, so aesthetically or maybe structurally doesn't work, but you can use, it's pretty much the same, loft and blend. So, you got it more or less. So original surface, panelized surface. Using the panelized surface, I flat it on the 2D plane, and then I blend it, and I get this element.
Can you unfold this?
Yeah. You can get it here. When we unfold it, sorry, I'm unfolding just, I think I'm unfolding everything right now. This is everything. So the first block, this part is the side of these little walls. Those guys, those stripes that we see here, are the upper and the bottom part of the model. So at the end you need to glue everything together, as always. But you can pretty much define any kind of object following these rules, these kind of techniques. Okay, so let's go to this is more or less clear how to deal with these kind of shapes and how to unfold it. Yeah. And let's see just one last example here. It's called polygon triangulation. Maybe it doesn't make much sense in the unfold process. This is more related to generate a nice object using this kind of library. But to unwrap or unfold this kind of object can generate many pieces. So maybe it's not the best example of something developable. So, but as you can see, you can generate pretty much very complex examples, just using transformations, extrusions, triangulate. So I'm going to talk a bit about this process. You are already familiar with the panelization. So we have a 2D, an array of 2D elements, and we apply that on a 3D surface, and we get a panelized polygon, for example. I'm going to add here other polygon, just in order to see the result. This is the panelized polygons. So you can see here, this is like our first part of the process. And then we extrude it. So, and also we get polygons. I'm going to use the same element. So I extruded that, but I didn't apply any offset. I just changed the cell size. And in this way, we get this kind of gaps between the cells. So, and then after the extrusion, I triangulate it. So I apply it again. You are not able to see anything, but if we add the wires, if we visualize the wires here in the 3D visualizer, you see that all the triangles are triangulated. So they are made of 3 triangles. So in the previous one, we have this one, and when we apply the triangulation, we have this one. So, and then we can apply a new extrusion. And we get the top of a triangles. So do you get it more or less? This is just a cascade processes. You can add any kind of transformation, modifiers as you want. So,
what is the offset of the extrusion?
the offset is here.
But there is no offset in the first one?
No, just scale. Because I don't need to offset it. I just need to change the scale of the cells. I could do that the same on directly on the hexagrid to the element. But sometimes you work with a closed polygon, you panelize that, but you need also a copy of this polygon, but offsetted in. So you need smaller cells to do a blend or to do other kind of process. So,
so the extrusion functions as kind of a...
This is not actually working as extrusion. The first one is working as an offset.
And creates a further set of objects.
Yeah. And you can work...
So in Grasshopper that would just... You could just put a scale and you would get all those objects.
You apply a scale by cells.
Yeah.
Yeah, but here it's a bit tricky to work in this way.
Because you need to copy all the objects.
Yeah. Mm-hmm. Do you use also Grasshopper?
Yeah.
Okay, cool.
The extrusion or the offset will always be along the normal.
Yeah,
Surface.
along the average of so we have a polygon with many triangles. I calculate the average of those normals, and then through this average normal, I calculate the extrusion. Sorry.
And there's no way to twist it.
Yeah, there is a way, but it wasn't working, and I didn't expose it in BBB. So it doesn't work in the way I want. So
Twisting the extrusion?
Twisting the extrusion. So
no, yeah, the thing that was twisted, that was with a blend before? Or,
yeah, you can use the same technique, so maybe blending it. But in the extrusion module, I didn't get a nice rotation, so along the axis. So in VL, the transformations work in other way than in before. So I need to find a better way to implement it. But this is for the second version, for the next update. So as you can see, we can use extrusion not just as a extrusion element, but to calculate offset of a polygon in 3D space, so, which is also handy in some situations. And also you can apply extra processes like triangulation, like here, to get more polygons or to get other kind of resolution, other kind of shape. So this is more or less that I wanted to show you regarding to examples. So, and if you want, we can go to the surface generators, so which is much fun to use and easier to use and understand. So, yeah, let's close this one and we can go to the surface modeling. Those are very, very simple examples, but I think anyone can use it. You don't need any BBB experience to work with them. So it's actually, yeah, you define everything via Bezier points. So it's, I don't know. So sometimes in some situations you have to load several times. So the Bezier, the editing framework is still in an experimental phase, so it needs some improvement. So if you don't see anything on the screen and you see a load there, just press it. So and you can define pretty much any kind of surface using 3 Bezier lines. For example, the first one is the smaller part, the smaller contour part. The second one is the bigger one. Is this part? Okay, let's show cursor. So you can see here. This is inverted, so in comparison with the 2D version. But you get the idea, you get the connection, no? Those are the same element, here and here. And this one, this little guy, here, is the first one, is this one. No? You get it? More or less. And the third one is just to define the path. So the interpolation path between the two starting polylines. So this is in this direction. So the 2D camera works with the right button and the wheel. And if you are not familiar with the editing framework, so for example, you can do some things like if you press I, you can see here 1 point. And you click twice, and you can generate a new point. Also, you can change the quality of a knot. So, for example, if you press 1, if you press 1, I change the kind of knot. So it has not any control points. So this is a sort of closed one. This is the other kind of Bezier knot. This is called corner one. And you can choose, the third one is the typical Bezier point, and the fourth is a symmetric one. So if you change it, both sides are changing at the same time. So if you want to understand it better, just go to the help patches on editing framework, and you can see how to deal with it. So, any questions about that? So do you understand more or less? You know?
What was the first renderer?
The first?
The first editor window.
The first editor window is... Oh, what happened? Okay, let's reload it. Okay, the first editor window is this little thing.
It's the two ends of the whole surface.
Yeah.
On the first end, you can on the other end.
Yeah.
This is the same shape. Yeah, it's a loft operation in 2D with Bezier lines. And also you have this guy. This is the second one, but it's inverted because we are looking through the other axis direction. Yeah, more or less clear. And also you can save it if you want as a surface, and you can use it in other process, or you can keep it in your library, in your surface library, to do other kind of operations. So I recommend you, if we are going to use this kind of surface as a base for other processes, panelization, extrusion, or these kind of things, you can save many resolutions, so many versions. One low poly, one medium poly, and one very, very high. So, and for example, the panelization you can do with a very high resolution surface, maybe an extrusion of the quads with a very low poly version. So, but you are working all the time with the same shape in some way, but you have many, many resolutions. Or just save the splines here. There is a folder called Files. I put everything together, so the Bezier curves all together, OBGs, surfaces, and SVG files. So in this case, you can put your name and generate your new Bezier line, and you can also reuse the Bezier lines in other patches. So it's a sort of modular way of working. So in this case, we are using 2D Bezier lines. We are working all the time in 2D space. So we are not working in 3D space. Our result is in 3D space, but we are defining the model in 2D space. So there is other example that I want to show you later. But before that, I want to explain some things about the red lines that we see here and these little green lines. So I prepared a set of alarms, for example, in order to work with the surfaces. Sometimes you are generating an object and you don't know really how long the polyline is, or the stripe is going to be. So it's nice to see that, for example, those red lines means that these polylines are bigger than 58 centimeters, which is our maximum paper size. No? And this is nice because when you are modeling, you see the errors on the mesh. Not errors, but you see the more conflictive parts on the model. And also not just the bigger parts, but the smaller one. Sometimes when you are going to connect two pieces and the pieces are smaller than 1 centimeter wide, they are a bit weak, and it's possible that you have some problems on this part. This is the reason because I generate this minimum size or minimum length and maximum curve length. Just to tell you, hey guys, so this is maybe, if you are going to develop this piece, maybe you are going to have some problems on this spot. So take care with that, or change it, or yeah. This is just a sort of alarm. And also here you can see some numbers in centimeters and in square meters. Those are the first 3 numbers are the bounding box of the element. And the fourth one is the total area of the element. So as you can see, it's less than 1 square meter, so it's not so big. And it's nice to have it here as a feedback, so to know, okay, this object I cannot fabricate it. I have not enough paper at home to do it, or it's going to be very big. Or
it's the bounding box of the plot, or
of the object that you see.
So when it is unfolded.
No, no, no.
Okay.
This is in 3D space. Those numbers are in 3D space.
Because you have another condition that is.
There, I'm using, as you remember, in the unfold data, there is also this kind of alarm. So if the piece is bigger than 58 centimeters, so it's red. So
can you also look at the total area of the paper that will be used, including the waste?
No, this is just the surface of the element, of the triangles.
Yeah.
So this is other thing. So normally when you are fabricating an object, depending on the eccentricity of the pieces, if the pieces are very, very irregular, you lose a lot of paper. So
and you
waste a lot of.
Implemented any packing?
No, this is one thing that I'm working on, but this is a very hard topic. So packing.
But you could possibly use Grasshopper for that part.
Yeah. Actually, when I use Grasshopper, I don't need to deal with this kind of things. So it's already implemented in Grasshopper.
Yeah, but you could generate the SVGs with this.
Load it in Grasshopper, yeah,
Pack it together.
if you want.
Yeah.
But I'm just thinking on a standalone solution for everything. So, and not all the people has access to Grasshopper.
No, exactly.
So we can use it, but this is for the whole people. So, but nice that you pointed.
Yeah. It's just interesting because you have a lot of tools built in for the fabrication.
Yeah.
That's it's interesting also to think about the packing again. But that's,
Yeah. But this is a big topic. Also, form finding is also a big topic. So design the form which structurally works without any problem.
Yeah.
We are not going in this direction because this is it's like 1 year of studies or 2 years.
Yeah.
But this is also interesting. For example, closed elements are more stable than open elements.
Yeah.
Or this kind of elements, this kind of curves, so are more stable than just a regular element. So this, if you apply some forces, it's going to be flat. But if you have a sort of element like a river or something like that, and you apply some pressure, it's much difficult to flatten. So because of this kind of curve. So there are some special surfaces that work very well structurally, but this is other topic. So the idea for this workshop is just understand the basics on algorithmic modeling and how to unwrap the files and do some objects, and maybe if you have time to use it as a projection surface or as a lamp or whatever. Okay. So if you want to make a pause, or do you want to keep going maybe the last 3 examples and then... Yeah? Okay. It's better to finish this part. Actually, the last 3 examples are very similar to this one, but the way of working is a bit different. So. Where I am? Okay, here. So we saw loft cubes 2D, and we are going to see loft cubes 3D. In editing framework, we have 2 kind of Bezier lines, 2D Bezier lines and 3D Bezier lines, and they are not compatible with each other. So actually, this is pretty much the same patch. So it's loft cubes and loft cubes 2D. This is VL, so you don't need to open it. It's just to see that I'm applying the same process for 2D and 3D splines. It's pretty much the same. So, and as you can see here, the auto load doesn't work, so you have to press load several times until the whole surface is loaded. And here on the right upper corner, we have an edit index that we can choose. For example, as you remember, for loft, we need 3 polylines. And we are defining the 3 polylines, the first 2 polylines here on the floor. So you can see here. On the X, Y axis, sort of. This is the first one. The second one is this one, which is this shape that we have here. Do you get it, more or less? And the third polyline, or Bezier line, sorry, the index 2, is how we define the path of those polylines. This is pretty much the same than before, but we are now in 3D space. We are not in 2D space. So we can do other kind of more complex interpolation. And also we have an auto axis, so you can define the axis and you can keep it static, and if or you can just make an auto axis. In some situations it doesn't matter, but in other situations you need full control of the axis, of how to call it, rotation axis of the path. So, yeah. And also you can close the surface. In this case, it doesn't make any sense because we are not working with a closed surface, but you can add it here. And also reverse the path, for example. You can see the shape has changed totally and is actually flipped. So the normals are flipped. So, and also you can define the resolution of the object. Those are common parameters for all the surface modeling modules. Yeah. And also, as like in the other example, you can save it as a surf or as a OBJ. The Svg Writer right now is a bit buggy, so I'm waiting for the new version that Kyle is doing. This is part of instance noodles, but yeah, I need some improvement. But in case that you need that as a file to export in other, or to load it in other software, you can generate also an X file via, instead of using how is the name? So there is from Surface DirectX 11, and also there is a DirectX 9 version. So with the DirectX 9 version, you can save X files.
What is that kind of file?
It's a sort of video game files that we use a lot. So maybe Matthias can explain that better.
I think it's one of the DirectX files, platformer for 3D objects.
Yeah.
I cannot tell you about the details.
Yeah.
But can you go between Rhino and this, for example?
Maybe X file is not really compatible, but you can export an OBJ file.
Okay.
So, and also, if you want, you can use the contribution. Do you remember this contribution? You can connect VVV with Rhino Grasshopper. Okay, there is a little plugin to connect Grasshopper with VVV. And you can do pretty much everything in Grasshopper and just send the results to VVV. But yeah, it works in other way. And not all the people can afford a Grasshopper Rhino license. So this is other thing.
Break into a university.
Or go to the university. But when I was studying, there was no Grasshopper. So there was just AutoCAD, and and 3D Studio. There was no way to do that on that time. Okay, let's see the last 3 examples, and we can take a break and if you want. So the last one of the group of loft is loft polylines. So I'm using pretty much the same way of designing, but instead, so I'm defining Bezier lines, and then I convert it into polylines, and then I loft it in a polyline loft. But this is pretty much the same that we did already. So this is the only difference is this conversion, so from Bezier to polyline. And in order to convert a Bezier into a polyline, so Bezier has no resolution. So you don't know, you just define some points and you have a cube. But you don't have resolution. You have to define the resolution in order to convert it in a polyline. So what the two polyline does is take care of this resolution, which is here, for example. So you can see the count is the resolution of this conversion. No, I get a Bezier line without resolution. I pass through the 2 polyline, and I get at the end a polyline with a resolution, with the same shape, sort of, than the original Bezier line. And also it has the same kind of usability than the other loft. So they are exactly the same. So, yeah. And also you can save the model, you can save the Bezier lines, and you can open it tomorrow if you want, and you have all the model here. And there is one thing that I forgot to mention, is there is a way to morph a bit the path. As you can see, so you can change so for example, they are distributed in an homogeneous way, all the polylines. The distance between the polylines is more or less the same. And with the morph, what we do is changing this distance a bit. So I'm compressing the positions here, and here they are more. There is more separation between the polylines. It's a sort of gamma or something like that. If you know that. But just to keep in mind that you can tweak a bit more even when you have the whole model defined. And also you can do that on the other directions. Okay? It's not updating. Okay. Yeah. Yeah, maybe it's not really relevant, but keep in mind that you can control other kind of parameters, so to change a bit more the shape. Yeah. Okay, so loft is more or less clear, I think. And let's go to the surface of revolution. I think this is the most simple way to generate an object. You just need one Bezier line, and you rotate it through an axis. And also you can choose the axis, like in the other example. In some situations, there is, for example, in this axis, we don't get a developable surface because the polyline is on this plane. So. But in this situation, we get this kind of shape. Yeah. And also we can pretty much define everything here. Oh, what happened? So this kind of shapes. Maybe the morphing thing is much easier to understand here. And applying this morphing process. Yeah. And this is pretty much how revolution works. Surface of revolution. Revolution works in other way. So, do you get it more or less? This little example? Yeah. So let's go to the next one. And this is the same, but working in 3D space. So I'm defining a Bezier line instead of in 2D space, in 3D space. And we can get other kind of twisted revolution surfaces. And this camera, the rotation and the zoom works with O and P. So this is the other camera that we have in BBB. There is an orbit 3D camera. And this is the normal one. This is what we use in editing framework. And also, if you are familiar with the editing framework, we can change the points along the axis, and for example, which is much easier to use. Yeah. More or less, you got it. And one little thing, if you are going to unroll it as interlocked tabs, and you want to close it in a nice way, you should use uneven resolution on your surface, because you need always, with an uneven resolution, you get even amount of quads. And this is what the interlocking tabs needs. It has to be even. So. And the resolution has to be uneven of the surface. You get it? So, yeah.
So would the interlocking tabs be better for, I'm going to travel to go home, so that I can take it apart easily? Because I think with the tabs, you can glue it together.
Yeah, it's easier and faster. Okay. It's good for prototyping, and also it looks nice. I really like it. So, and you are not adding extra material. So in case of you are applying a lot of heat or something like that, with glue and heat is not good, for example. So it's more stable and more elegant in some way. You are not adding extra material. You are not adding anything. So you are just transforming paper in something. So, okay. So let's take a break and think about everything.
You can say when we start, we will start. We go through one example, really fast, like here, like for the projector guys yesterday, and then everyone goes also to do the next round. One through from scratch, one process, quad grid, another quad grid, turn it,
Just
or unfold.
one of the examples, and I'm going to ECU and see the
No, this is afterwards. I would say, because we start next 15 minutes, you're doing one process from that, cut, and then everyone starts.
Okay, just to understand the work.
Just to understand, one cut, one run through, very easy, some boxes, turning, spinning, things, because we go to Illustrator, and then you also have the feeling that you can also start into it going one pipeline.
Also, our paper size is like 60 by 50. 60, I think. We have to make it a bit smaller. Have some laptops on the bottom.
But this we will see next. Just to say what our plan is for the next thing. We get more patching and the normal heating break is now on the side. Look. Now when is it finished? At 1 or 2?
At 1.
At 1, yeah, so it's finished.
It's finished now. So if you have some questions or you don't understand anything or...
I have a big question. There are two machines having an NVIDIA M330 graphic card, maybe one of you also, and it's not rendering. Is it a DirectX 11?
Yeah, maybe. I have some modules on DirectX 9, but it's not completely running on DirectX 9. I mean, it's just a...
It's weird because there are some onboard and we can render it. This will
I'm
be
thinking of
and then the Dell computer cannot handle it. M330 NVIDIA. Yeah, it's like the old Macs and Dell. And the only two computer where it's not visible. Okay, that's the shader mode, it's really that the graphic card is not supporting maybe the shader mode style what he's using for the laptop. It's also a massive naja, war interessant. Genau.
I'm just using actually there is some modules generate a mesh, generate the files, but this is just more for to have it all together in the video. So if you want to go to it, you can do it. We are going to do that after, but this is just for us. Okay. So I'm going to close this one. And I'm going to open one of the examples. So for example, panelization and blend. We generate the pieces, all the pieces. We have the pieces here all together, and we just add here an Svg Writer with the unfold list, the whole list. As you can see, it takes some time to unwrap everything. This is not the most... okay, I'm going to apply here an evaluate in order to work in a better way. And as you can see here, we have all the pieces together. And now I'm going to add a path to this file, Svg, select, and a name. We are going to call it plan. Okay, we got it here. We see that we have some problems on the paper side, so we need to change it here, the amount of columns. Let's see if it fits better. Okay, we don't have any red information here, so now we can able to export our model to the Svg file. Suck. It takes some time. Fine. I unevaluate this one. I open this folder, and we have here an Svg file. We can open it with Google Google Chrome, for example, and we can see all the vector files. With the numbers and object. Yeah, this is a vector file already. And also we can open it in Illustrator. Shall I show Illustrator online? I mean, there is no problems with license and this kind of stuff. When you show commercial product.
YouTube tutorial for Illustrator.
Maybe they pay, I don't know. That's not used, okay, but we are working for now.
Do you need Illustrator necessarily to open this?
No, InDesign also. You can use
Inkscape.
Inkscape. InDesign is the other one. Sorry, Inkscape.
Inkscape is open source or free at least.
Yeah. But Illustrator has some extra features. You can select by color, stroke color or these kind of things, which is important for when you are dealing with a lot of pieces. So every piece has one color. And on every piece, the part of the pieces, so the contours or the perimeter, the inlines, have different width, so stroke width. So you can select all the perimeters of the whole structure, or you can select by color, and you are able to select just one stripe with all the elements. You can select in many ways. But I don't know if InDesign and Inkscape has these features. So now we
dashed
have
lines, it's going to perforate. The dashed lines, the cutter is going to perforate. So you can follow
Yeah. The easiest way to do that. And as you can see, we are almost on the border of paper size in Illustrator. Yeah. And in order to work with them, for example, I'm going to ungroup it. And I'm going to select by color, for example, a stroke color. The tolerance in 0. Right. And I use the, how is it called, magic wand tool. And when I select, I have selected just all the elements on this stripe. Ctrl G to make a group, to easily work with it. Sorry. And we can do pretty much the same with all the pieces. So in this case, we are working with a paper space of 60 by 50. So we generate a new document with more or less this size. So 60 by 48 centimeters in my case. I copy what is going on here? I copy some stripes, and in this case the pieces are bigger than our paper space, but we can copy maybe those little guys. So as you can see, if I don't select by color, you can make a lot of mistakes. So it's better to follow this way of working. So select by color stroke, tolerance in 0, group, bang, group, sack, group, und sack, group.
Das braucht man ja nicht mehr hier. Nächstes Ding. Kannst du das VGS aufnehmen? Nimmt jemand VGS auf? Ja, gut.
We can put all together in our paper space. For example, if we are using a cutting plotter with a knife, or this kind of one-axis plotter, it's better to put the pieces along the axis. And in this way, you are not moving the material so much. So it's better and you get less errors. If you are using a laser cutter, it doesn't matter, so it's quite okay. And also you don't need to use a plotter, so maybe you can use a printer and cut it manually, or even you can put it on the floor and project it and mark it if you are dealing with a big piece or something like that, or you are doing that with a cardboard. So you don't need a plotter, so you just need the SVG file. So. And then when you have the model here, you can send it to the plotter using the software that the plotter gives to you. Yeah, this is more or less the workflow for the fabrication process. Okay, cool.
And the dotted lines, old lines, and the dotted lines, these are just followed.
No, they are just cutted. Actually, they are cutted. So
But not cut through, but just for
they are
folding.
cut
Yeah,
through.
meant
They are
for
cut
folding.
through, but
Are they cut through? Really?
yeah, all the elements that you see are cutted through. So
No, but so the outline is cut through.
yeah,
But these little.
they are segments.
But you don't cut all the way through.
No, you don't cut all the way through. You just mark it. So pop, pop, pop,
Yeah.
pop.
So this is.
And when you fold it, you fold it
Yeah.
by the line of points.
Yeah.
There is other way to do that, but you need a thicker material. So with this kind of material, it's a bit risky to do that. So mostly if you are working with a knife.
You just print it and then you know, okay,
Yeah,
I fold it.
yeah. I did that with other materials, a bit more heavy.
Yeah, I've laid laser cut cardboard.
Yeah.
And then you can set the laser settings
Yeah.
all the way through.
Or very low, yeah. Just to
And then you
mark.
can-
Yeah. With laser plotter, you have more flexibility, but it's also possible to define this kind of inlines not as a dash, but as a single line. So if you are using other kind of technique, so I didn't explain that, but it's already in the application. So it's everything pretty much done. Cool. Don't need to think so much about the boring process. So, thank you very much, and see you in 2 years.